Hi, welcome. In our previous tutorial, we looked at confidence interval for population proportion. But in this tutorial, I'm going to take you through confidence interval for population variance and standard deviation. That's the chi-square distribution. So the formula we are going to use is n-1 multiplying s squared divided by chi-square right less than sigma square less than n-1 multiplying s squared divided by chi-square left. Remember that the symbol for population variance is sigma square, and then the symbol for sample variance is s square. And this particular one that looks like an x and it has a square, we read it as chi-square. Okay, so this is chi-square right and this is chi-square left. Now you can compress this formula like what we did in confidence interval for mean and confidence interval for proportion. This is because their denominators are different. This is chi-square right, which will give you different value, and this is chi-square left, which will also give you different value. Now we use this when we are estimating confidence interval for variance. Okay, but when you want to estimate confidence interval for standard deviation, you are going to take the square root of this and then the square root of this. But this place should be a sigma without a square. So this shows that you are estimating confidence interval for standard deviation. Remember that when you take a square root of a variance, you get a standard deviation. So what then is a chi distribution? Now, unlike the normal distribution, the chi distribution cannot be negative. So you see that the values move from 0 upward, and then they are skewed to the right. Now, the reason the denominators are not the same is that the chi-square distribution is not symmetric. So this is how it looks like. So this one has a degree of freedom of 1, this has a degree of freedom of 3, this has a degree of freedom of 5, and this has a degree of freedom of 10. Now, as the sample size increases, you know that the degree of freedom will also be increasing, isn't it? Degree of freedom is equal to sample size minus 1. So as the sample size is increasing, the degree of freedom will also be increasing. And as the degree of freedom increases, the chi-square distribution approaches the normal distribution. So as you can see, this has a degree of freedom of 10 and this has a degree of freedom of 5. The one with a degree of freedom of 10 kind of look like a normal distribution than the one with a degree of freedom of 5. And chi-square values cannot be negative because the distribution is skewed to the right. Okay. Under confidence interval for mean, I taught you how to find the z-scores and the t-scores. So in this also, I'm going to show you how to find the chi-square values. So let's take this question and see how to do that. Question 1 says, find the values of chi-square right and chi-square left for a 95% confidence level when n is equal to 20. Now to solve this, first you need to get your chi distribution table. And then you find area to the right, you find area to the left, and then you find the degree of freedom. So let's see how to do that. Now to find the area to the left, you can use the formula 1 plus c all divided by 2, where c represents the level of confidence in decimals. And then to find the area to the right, you use the formula 1 minus c divided by 2. And then to find the degree of freedom, it is n minus 1. Question 1 gives us a level of confidence of 95%. So in decimal, that will be 0.95. So first we find area to the left. To get the area to the left, it is 1 plus c divided by 2. And that will give us 1 plus 0.95. Since our level of confidence is 95%, so in decimal is 0.95. So we have 1 plus 0.95 divided by 2. And that will give us, when you add 1 and 0.95, you will get 1.95. So when you divide it by 2, you should get 0.975. So after getting the area to the left, then you find the area to the right. Area to the right should be 1 minus c divided by 2. And that will be 1 minus, the confidence is 0.95. So 1 minus 0.95 divided by 2. And that will be 0.05 divided by 2. And that will give us 0.025. In short, whenever you are able to find the area to the left, you can get the area to the right directly by saying 1 minus area to the left. So if you take 1 minus 0.05 0.975, you see that you get the same answer, that is 0.025. So you can choose to do it anyhow you want to. You can find the area to the right first and then find the left by saying 1 minus the right. So next, let's find the degree of freedom. Degree of freedom is n minus 1. So to get our degree of freedom in question 1, it is 20 minus 1. And that should give us 19. So now we know the area to the left, we know the area to the right, and then we know the degree of freedom. So let's go to the chi-square table to find chi-square right and chi-square left. Now, when you check the chi-square table, now we have area to the left as 0.975. So you check here. As you can see, they've written chi-square sub 0.975 here. So it means you can use the area to the left to get the chi-square left. And then we got 0.025 for the area to the right, isn't it? That is chi-square sub 0.025, this one. It means we can use the area to the right to also find a chi-square right, okay? Also, we got the degree of freedom to be 19. So this is 19 here. So when you trace this, we'll get 8.907 as our chi-square left. And then when you check it for this also, we get 32.852 as our chi-square right. So keep it in mind that we use the area to the left against the degree of freedom to find a chi-square left. And then we use the area to the right against the degree of freedom to get a chi-square right. Okay, so in this, our chi-square left is 8.907 and our chi-square right is 32.852. Remember, in every question, your chi-square right will always be bigger than the chi-square left. So let's take the second question. The second question says, find the values of chi-square right and chi-square left for 90% confidence level when n is equal to 18. So to solve this, we find the area to the left, that will be 1 plus c divided by 2. So our c here is 90%, that's 0.9 or 0.90. So we have 1 plus 0.90 divided by 2, and that will give us 0.950. Then we also find the area to the right. Area to the right should be 1 minus c divided by 2, and that will be 0.1 divided by 2, and that will give us 0.050. Remember, I told you that whenever you get the area to the left, you can say 1 minus area to the left to get the area to the right. So check 1 minus 0.950. You see that you can get 0.050 without necessarily using the formula 1 minus c divided by 2. Then you find the degree of freedom. So the degree of freedom should be the sample size minus 1. So the sample size is 18, then we subtract 1 from it, that's 17. So we go to the chi-square table. So we got the area to the left as 0.950, and then we got the right as 0.050. So we have it here also. So what was the degree of freedom? The degree of freedom was 17. So when you check 0.975 against the degree of freedom of 17, you get 8.672. And then when you check the area to the right against the degree of freedom of 17, you get 27.587. So that is the answer to this as well. So let's proceed to how to estimate confidence interval for variance and standard deviation. Example 1 says, find the 95% confidence interval for the variance and standard deviation of the nicotine content of cigarettes manufactured if a sample of 20 cigarettes has a standard deviation of 1.6 milligrams. Now to solve this, we recall the formula for confidence interval for variance, which says n minus 1 multiplying s squared divided by chi-square right less than population variance less than n minus 1 multiplying s squared divided by chi-square left. When you look at the question, we know the sample size, which is n to be 20. So our n is 20. And also, standard deviation has been given as 1.6 milligram. So our small letter s is 1.6 milligram. Now, if the question had given you variance, then it won't be s, it will be s squared, okay? But because the question says standard deviation, so standard deviation is just s without the square. The variance is s with a square. So now that we know our n and then we know s, we need to find a chi-square right and chi-square left. So let's do that somewhere. So to find a chi-square right and chi-square left, remember, you need the area to the left and you also need the area to the right. So let's find the area to the left. Our confidence level is 95%. So in decimal is 0.95, isn't it? To get the area to the left, it is 1 plus c divided by 2. And that will be 1 plus 0.95 divided by 2. And that will give us 0.975. When we find the area to the right, it should be 1 minus c divided by 2. And that will give us 0.025. Remember, I told you that if you get the area to the left, you can say 1 minus left to get right. Okay, so area to the right is 0.025. So let's find the degree of freedom. So the degree of freedom will be 20 minus 1, that is 19. So we go to the chi-square table. Area to the left was 0.975, so this is it here, 0.975. And then the right was 0.025. So the degree of freedom is 19. So when you check 0.975 against the degree of freedom of 19, you get 8.907. And then when you check 0.025 against a degree of freedom of 19, you get 32.852. So our chi-square right is 32.852 and our chi-square left is 8.907. So now that we know the chi-square right and then the chi-square left, then we just go ahead and substitute them into the formula. So we are going to have 20 minus 1 multiplying, since s means standard deviation, we put 1.6 there and then square it. If the question had given us variance, you just substitute in place of s squared without squaring it anymore. Okay, so you have 1.6 squared divided by, the chi-square right was 32.852, so we substitute it there, less than population variance, less than 20 minus 1 times 1.6 squared. As for the numerators are the same. It's only the denominators that are different. Okay, so our chi-square left is 8.907. So when you check 20 minus 1, that will give you 19. Now 20 minus 1 is 19. So 19 times 1.6 squared should give you 48.64. So you are going to have 48.64 divided by 32.852 less than population variance less than 48.64 divided by 8.907, since the numerators are the same. Okay, so when you enter 48.64 divided by 32.852 on your calculator, you get 1.48. Then the upper limit will give you 5.46. So we can conclude that one can be 95% confident that the population variance is between 1.48 and 5.46. To estimate confidence interval for standard deviation, since you've been able to get a confidence interval for the variance, we just take the square root of the variance to get a standard deviation. So when we take the square root of 1.48 and then we take the square root of 5.46, we are going to get 1.22 less than population standard deviation less than 2.34. Here I use a sigma with a square because I'm estimating population variance. But in this one, I didn't bring the square because I'm estimating population standard deviation. So be very careful about that. So we can conclude that one can be 95% confident that the population standard deviation is between 1.22 and 2.34 milligram. So that is the final answer to this. So let's take another question and see. Question 2 says, find the 90% confidence interval for the variance and standard deviation of the sugar content of icy cup made for sale to students on campus. If a sample of 16 icy cups has a standard deviation of 1.21 milligram. So to solve this, so first we recall the formula for estimating confidence interval for variance, and that is n minus 1 multiplying sample variance, that is s squared, divided by chi-square right less than population variance less than n minus 1 multiplying sample variance divided by chi-square left. from the question, we know our sample size n to be 16, isn't it? And we've been given standard deviation to be 1.21. So our small letter s is 1.21. If the question had said variance is 1.21, be very careful. It means that s square is 1.21 rather. But because the question says standard deviation, is just s. So s is 1.21. So next, we need our chi-square right and the chi-square left, isn't it? So to get a chi-square right and chi-square left, we have our c to be 0.9, that is 90 over 100. The area to the left is 1 plus c divided by 2. So 1 plus 0.9 all divided by 2 give us 0.95, isn't it? And then to get the area to the right, you can say 1 minus area to the left. So 1 minus 0.95 will give us 0.050 or 0.05. Okay. You can also use 1 minus c divided by 2. You get same answer. Now, we need the degree of freedom, which is 16 minus 1. The sample size is 16, then we subtract 1. So we get 15. So we go to the chi-square table. Now, the area to the left is 0.95. The right is 0.05. So our degree of freedom is 15. So let's check the area to the left against the degree of freedom of 15. We get 7.261. So this is the chi-square left. And then let's check the area to the right against the degree of freedom of 15. We get 24.996, and this is the chi-square right. So our chi-square right is 24.996 and our chi-square left is 7.261. So let's substitute that into the formula. So we're going to have 16 minus 1 multiplying 1.21 square divided by 24.996 less than population variance less than 16 minus 1 multiplying 1.21 square divided by 7.261. Please remember that when the question gives you a variance, just substitute it without squaring anymore. But because the question gives you a standard deviation, you need to square it in the formula. Standard deviation is just the s part, so you still need to square it. So 16 minus 1 is 15. So when you multiply 15 by 1.21 square, you get 21.9615. Okay, so we can have 21.9615 divided by 24.996 less than population variance less than 21.9615 divided by 7.261. So 21.9615 divided by 24.996 should give you 0.8786. And then the upper limit should give you 3.0246. So you can conclude that one can be 90% confident that the population variance is between 0.8786 and 3.0246. You can leave your answer in 2 decimal places. So this will be 0.88 and this will be 3.02. To estimate the confidence interval for the population standard deviation, you just take the square root of the variance. So square root of 0.8786 less than population standard deviation less than square root of 3.0246. So square root of 0.8786 will give us 0.937. And then square root of 3.0246 will give us 1.739. So we can conclude that one can be 90% confident that the population standard deviation is between 0.937 and 1.739. You can leave your answer in 2 decimal places, okay? So this will be 0.94 and this will be 0.74. Now let's look at another form of question you can be given in this topic. Question 3 says, find a 99% confidence interval for the variance and standard deviation of the data given below: 12, 15, 8, 20, 10, 17, and 10. So to solve this question, let's recall the formula, which says n minus 1 multiplying s square all divided by chi-square right less than population variance less than n minus 1 multiplying s square divided by chi-square left. Now, from the question, when you count the data values, 1, 2, 3, 4, 5, 6, 7, we have 7 data values. So it means that the small letter n is 7. Since s square means variance, then we can go straight and then find the variance. So what is the formula for variance? S square, which is variance, is equal to summation x minus x bar all squared divided by n minus 1. For standard deviation, it is rather square root of this, but we want to find a variance straight. Okay, so that is summation x minus x bar squared divided by n minus 1. So to do that easily, we can create a column for x. So we list the values 12, 15, 8, 20, 10, 17 and 10. Then we find x minus x bar separately. And you know x minus x bar means deviation, d. Okay, but we don't know the x bar. So let's find the x bar. But we don't know the x bar, isn't it? So let's find the x bar ourselves. So to get the x bar, it is summation x divided by n. So how do we get summation x? It is 12 plus 15 plus 8 plus 20 plus 10 plus 17 plus 10. So when we add everything together, we get 92. And the sample size is 7, isn't it? So that will give us 92 divided by 7. So when you check 92 divided by 7, you get 13.14. So it means that the sample mean x bar is 13.14. So to get a deviation, the first one we take 12 minus 13.14 and that will give us negative 1.14. You do that for the second one, you get 1.86. So 8 minus 13.14 is negative 5.14. So you do that to the last one. Okay. Then you find deviation square, that is x minus x bar square. Okay. It means that we should square each x minus x bar. Please, when you are putting this on your calculator, make sure you bracket it before you square, okay, so that you can get the correct answer. So negative 1.14 square will give you 1.2996. Then 1.86 square is 3.4596. So you'll be squaring each of the deviations up to the last one. So after getting each deviation square, then you add everything together. So when you add everything, you get 112.8572. So you come here and then substitute that into the formula. So you see that this is summation x minus x bar square. And this place means x minus x bar square. So the summation of everything. So we substitute it here. So we have 112.8572 divided by n minus 1. So our n is 7 minus 1. So when you put that on your calculator, you get 18.8095. So our sample variance is 18.8095. You can leave it in 2 decimal places and that will be 18.81. So after getting the variance, now we need the chi-square right and then the chi-square left. Now here our C is 99% and that is 0.99. So to get area to the left, we say 1 plus 0.99 divided by 2 and that will give us 0.995. And then to get the area to the right, it is 1 minus 0.99 divided by 2 and that is 0.005. Or you can also say 1 minus this area to the left to get the right. Okay. So after that, then you find the degree of freedom, which is sample size minus 1. So that's 7 minus 1 and that will give us 6. So we go to the chi-square table. So we have area to the left as 0.995, which is here. And then area to 0.005, which is here. And then the degree of freedom is 6. So when we check chi-square left, we get 0.676. And then chi-square right is 18.548. So our sample size is 7. And then our variance, which is s square, is 18.81. Please, not standard deviation, but variance. Okay, 18.81. And then the chi-square right is 18.548. And then the left is 0.676. So we are going to substitute this into the formula. So that will give us 7 minus 1 times 18.81. For this, you won't square it again. The reason is that the 18.81 is a variance. It's not a standard deviation. So you don't need to square it anymore. Divided by 18.548 less than population variance less than 7 minus 1 multiplying 18.81 divided by 0.676. So 7 minus 1 is 6. So 6 times 18.81 to 2 decimal places, you get 112.86. Okay. So we are going to have 112.86 divided by 18.548 less than population variance less than 112.86 divided by 0.676. So when you check 112.86 divided by 18.548, you will get 6.08. Less than population variance, less than 112.86 divided by 0.676 will give you 116.95. So you conclude that one can be 99% confident that the population variance is between 6.08 and 116.95. So after that, then we estimate the confidence interval for the population standard deviation. So to do that, we are going to take the square root of the variance. So we're going to have square root of 6.08 less than population standard deviation less than square root of 166.95. So square root of 6.08 will give you 2.47. And then square root of 166.95 should give you 12.92. So you can conclude that one can be 99% confident that the population standard deviation is between 2.47 and 12.92. So I'm going to end this here for now. You can check the link to the next topic in the description area below. Thank you.